Hi everyone, this is Sharan here. Welcome to my channel. Today we are going to start about exploratory data analysis and feature engineering. So what we are going to do in the next few days is we will be picking up few use cases or data sets, and then we will be practicing more of the exploratory data analysis as well as the feature engineering that would be done on those specific scenarios, use cases or projects, like whatever you can call them. So the first one that we are going to pick today is the Titanic Dataset. So this is a very popular dataset. So almost anyone who have learned data science would have used this particular dataset to understand better about the problem and how to do feature engineering, how to do the prediction and so on. So what we will do is we will go with this popular dataset. So what we are going to do is, first step is we are going to do the data analysis. So as part of any project, so what you would do is you would first analyze the data. So when I say analysis, like what would happen is it can be divided into further 3 steps. Like we will pick up one variable at a time and do the analysis, which is called as Uni-Variate Analysis. Bi-Variate means that 2 variables at a time and then seeing how they are related to each other and look for patterns. And multivariate is when we try to combine more than 2 attributes or 2 features to see how they behave together. So that's the multivariate analysis. And after doing the analysis, then what we do is we go for the data transformation. For example, that would be attributes such as age and in this particular case fair and so on. So where if I take age, like age can range between like 0 to 100, like whatever it could be, and that could be some patterns. For example, in case of Titanic dataset, there is a very clear pattern, like people of very young age and very old age had a higher probability as compared to someone in the age between like 18 to maybe 30. So in these cases, what we can do is, instead of using the age as a number, we can try to group them into different categories and then see how the output or how it improves in improving the accuracy of the model. So that's about the data transformation. So we are not creating any new feature here, but what we are trying to do is we are trying to use the feature that is already existing, but we are going to tweak it, transform it, and then see how it improves or how it helps in improving the accuracy of the model that we are using. And the final one is about the creation of new feature. So here, when I say creation of new feature, like one, it could be like use of an external data set. Like we try to bring some kind of an external data set and then see how it helps in improving the model. Otherwise, what we can do is we can use the existing features, the attributes that we already have, and then try to combine them and then create a new feature and then see how helpful it is in improving the accuracy of the model. So when we do the data analysis, like when we consider data analysis and feature engineering, it can be divided into these three parts. Like one is the data analysis, second one is the data transformation, where we are not creating any new feature, we are trying to use the same feature, transform it a bit, and then see how it helps in our analysis or in the improving the model accuracy. And the final one is creation of a new feature as such, by combining the existing one or by bringing an external data set into the analysis. So the first example that we are going to see, which is the Titanic dataset, we are going to divide this into 3 parts. So the first part will be data analysis part. So we will be analyzing the data that is already available. And then second part, which will be for the next session, we will be going through few techniques that can be used for data transformation. How to transform an existing data into a new data, how to create buckets, how to create a string category into a numeric category so that it can be helpful in the model. And then final part, the final session of this Titanic dataset will be creation of new features, where we will be going through how to use the existing features and combine them to create a new feature. So these would be really useful in your data analysis as well as in feature engineering. When I say feature engineering, it is nothing but a creation of new features or modification of the existing features in such a way that to see if it can help us in improving the accuracy of the model. So in most of the title competitions, you would have seen like the input data which is available will be same for anyone who is participating in the competition. But what differentiates a winner from others is the feature engineering part. Almost all the algorithms that we are using is almost standard, like anyone can use the algorithm, but what differentiates the winner is how much feature engineering has been done, how much effort has been put into the problem in creation of new features or transformation of the existing features. So we will pick up this example and then see this process end to end, and let's go into the tutorial, and let's go into the first part and see how to do the data analysis for the Titanic dataset. And before going in, if you like what I am doing here and if you are learning something new here, please give a thumbs up and subscribe to my channel. Let's go into it. In order to do the data analysis, we need some of the libraries. The libraries that we are going to use today are NumPy, Pandas, Matplot library, as well as Seaborn. So Matplot library and Seaborn is for doing the visualization. So for any data exploratory analysis as well as feature engineering, some of the packages that you need to be really good is Pandas library, NumPy, and visualization libraries. So these are all like a must have for you to do a good data analysis. So let's import all these libraries, and let's read the dataset as well. So what I'm going to do is I'm going to use the Titanic dataset. So the dataset that we are going to use is from Cadle. So it has a training as well as a test dataset. I will provide you the links where to download these data, as well as I will be providing link to the GitHub repository from where you can find the code that I'm using today. And the first one is, let me read the data set after importing the packages required. So after reading the data set, let's just display the top 5 rows and then see how they look for test as well as for training. So if you see, so this is how the data set looks like. So it has about 10 to 12 attributes like passenger's ID, survived, which means that whether they did survive or not. Like 1 means they have survived, 0 means they were not able to survive. So P class is the passenger class, name of the passenger, sex, age, and number of siblings, and part is like number of parents or children for the passenger that we are looking into, and the ticket, what was the fare, and the cabin, and embarked. Embarked is from which port the passengers had boarded the ship. So this is how the dataset looks like. So this is the training dataset. So usually while working on the models, like what happens is there will be a training dataset and then the test dataset. So in the training dataset, in case of all these happens in supervised learning. So in the training dataset, we know exactly what happened to those data. In this particular case, we know which passengers survived and which passengers did not survive. And using this, what we will do is while working on the competition or while working on similar kind of use cases. So let me show you the test dataset. So in the test dataset, as you see here, we have all the details exactly same as the training dataset. But what we don't have is we don't know about which passengers survived and which passengers did not survive. So what we do is we use the training dataset, we do the analysis, based on the analysis, we identify the features, we use those features to build a model that can predict the survival. And what we do is we pass on the test data set to this particular model and then make the prediction for the test data set. So that's how it usually works. And so this is how the test data set is looking like. And moving on to the exploratory data analysis, which is the first part. So what we are going to do is we are going to first try to understand this particular data set much better. So the first one is before starting the data analysis, first try to understand what is the data that you are going to work on. What are all the different attributes. So here in this case we have 12 features, as you see here. If you want to understand about what they mean in detail, I will provide you the link. So if you go here, you can understand, you can see what are all the variables, what is the definition, and what 0 or 1 means. In case of ticket class, what 1, 2, and 3 means. So this is about the data set. So now we also using the .info functionality, we can also get an understanding about the data type. For example, we can see that the passenger ID, the survived, and P class are all integer. The name and sets are object because it contains string, and age is float. So maybe it has been given if there is someone maybe combination of year and month. So this gives us an understanding about how the data is looking. So now moving on to the next one, using the describe functionality, what we can do is we can understand about the distribution of the numeric data. For example, all these attributes are numeric attributes, it could be integer or float. We can see what is their mean, how much is the standard deviation, what is the various percentile, what is the minimum value, maximum value. This helps in understanding about how the data is distributed, as well as it helps us to understand about whether there is any outliers. So if you see here, when I see the FAIR, the mean value is 32, whereas the highest value is 512. So we can clearly see that there is some kind of an outlier. So even the 75th percentile is 31, which is 75th percentile is 31, which is slightly below the mean, but the highest value is 512. So which means that the FAIR has a large number of outliers. So this helps to understand the different attributes, how their distributions are, and so we can get an idea about what kind of transformation would be required looking into it. Maybe as you practice more looking into this directly, you will get an understanding of how I can transform the data. So if I see age here, the mean age is close to 30, 75th percentile is 38, whereas the maximum is 80. Again, we can see that could be some kind of an skewness, majority of the people are maybe below 40 years, and there are few elders, so it's slightly skewed. So this helps us in understanding better about the data set. So whatever data that you are going to work on, the info and the describe functionality will give you a quick high level overview about what is the data and what is the data that you are going to work on. The important one is trying to understand about the missing values. So this is really important because when we are working on building a predictive model, in this case, when the data set has a large number of missing values, it will be really difficult for us to make accurate prediction. So here in this case, on the training data set, we can clearly see that the age is missing for about 177 people, and we don't have cabin details for about 687 people. 687 is more than 2/3 of the data set doesn't have this particular data. So maybe if you asked me, if the data set more than 2/3 of the data set is not having a particular information, then I would then it means that maybe pretty much it is not going to be much of an use to use this data set, because anyway majority of them don't have this data. So if we are trying to use this in our model, it's going to be not so accurate. So having a look into this information directly here tells me that it might not be useful in whatever model, predictive model that we are going to build on. And the next one is having an understanding about the test data set as well. So here in this case, since this is a title competition, we know about the test data set. So the competition is to make the prediction on the test data set, and then everyone will be ranked based on the accuracy. So in a real life situation, what happens is we don't have this test data set. So we train the model and we try to split the data that we have into a training data set, remove the column that we need to predict, and then try to make the prediction and then see how good the model is working on. And then what happens is once the model is trained and everything is ready, so then we put the model into production, and then when the new data comes through, it will be passed into the model to see to make the prediction. So the test data set is not separately available. So whereas in case of title competitions, these will be provided to us so that we can make the prediction and then see where we stand based on the accuracy. So in the test data set as well, we can see that age and cabin are missing for majority of the people, and apart from that, FAIR is missing for just one person. That is fine. On a large data set, just one row is missing is still fine. But if we want to replace that FAIR, we can try about using doing some kind of analysis, seeing generally the FAIR would be based on, let's say, age, the class in which the passenger is traveling, and maybe depending upon the port where they had been boarded. So maybe what we can do is we can use the combination of these and then see for the value that is missing, what is the age of the particular passenger, what is the class in which the passengers had traveled, what is the port where they had embarked, and using this we can try to use the mean of that particular combination and then replace the missing data. We can also think about something similar to see if the age and the cabin details can be replaced. So that's very important. Like first we need to understand about the missing data, like how much data is available and what is missing, so that we can be better placed to see like what needs to be done in order to replace the missing data, or whether is it worth enough to just ignore them. So having a look into it will help us in making those decisions. And moving on to the actual data analysis to see what the patterns between different attributes. The first one here, what we are trying to do is we are trying to see whether the survival rate between a male and female is different. If it is different, how different it is. So I'm just going to do a group by. So this will be the output will be a tabular data. So as you see here, we can see about 74% of females have survived, whereas only 18.8% of male have survived. So let's say we want to do this on a plot. So depending upon your preference, so we can see the same is represented in a graphical format. So here we can see the magnitude of the difference. So female had a higher probability of surviving, whereas male had a very less probability of survival in this particular accident. And then moving on to the next one, we are going to analyze how the variable age affects the survival. So here I'm going to use the Seaborn library to do a twit plot. So as I have explained in the past, the Seaborn package helps us to make twit visualization with just in the line of code. So there is no need to it also ensures that the labels are being populated. So without much of an effort, it's very easy. It's most preferred package when we are trying to do the data analysis. So here we can see the data is distributed by age, and then on the left we have how many people did not survive, and then right survived equal to 1 is how many people survived. So here we can see that a majority of people of age group maybe 18 to 40 did not survive. That is a huge spike. So here this is looking more like a normal distribution, like a bell curve, whereas here we can see the majority of people on this side did not survive in this accident. So all these are really important. While doing this analysis, what you need to understand is you need to understand which attributes are playing an important role. So what happens is after doing this analysis, we will be picking up or using those attributes, those features in order to make the prediction. Moving on to the next one, the scatter plot. So what we are going to do is we are going to do this similar analysis. So for age, but what we are going to do is we are going to use the scatter plot and differentiate how many people survived and how many did not survive. So here the orange ones are the people who have survived. We can see that people of age below 10, most of the children's did survive. There's lots of orange dots as compared to blue dots in this area, and we can see the middle portion here having a lot of blue dots. Majority of them did not survive. So this helps in understanding age will be an attribute which will be really useful in order to make our prediction. So this is something that we have to make use of. And having a look into these attributes, it tells us that since majority of the people on below 10 and maybe above 50 had a good survival rate, so maybe we can consider about bucketing this particular feature. So instead of using it as a numeric number between 0 to 80 in this case, we can see how to combine them into different groups and then see if it helps in improving the accuracy of the model. In most cases it would do. Rather than using an integer value, if we try to group them into buckets and then if we use it in our model, it will generally improve the accuracy of the model. So that's something that we can infer from these kinds of outputs. And then next one is about the fare. So we can see how the fare has a correlation with survival. We can see in case of fare, the majority of them were towards the lower end. There are few outliers towards the right hand side. So if we see there is not enough data for fare more than 100. but so this graph tells us that it's heavily skewed, and hence if we are going to use fare in our data set, it's better to maybe bucket them. So create a lot of buckets towards values less than 100, and then maybe bucket all the values over 100 as a single group, like an outlier, and then see how it helps in improving the model. But as such, since this particular data set has a huge number of outliers, if we directly use the values as it is, it might not help in improving the accuracy of the model. So the next one is we are going to see how the fare and age combination is looking. So even here we can see that the data is densely populated in this particular area, where majority of the passengers who are traveling did had a fare which is less than $100, between $0 and $100. So it would make sense for us to create multiple buckets and then split them off and then see for any patterns. Similar for age as well. Later, there are lots of people who survived here, and here in this graph it doesn't clearly say us that people on this particular segment did survive, had a survival probability higher, but we can see as we move towards the right, as we move towards the higher fare, the probability of survival seems to be slightly higher. And so we can see that there's a lot of orange dots here, as compared to people who had traveled in a low fare. And doing further analysis, seeing how various attributes behave in combination with others. So this one is the P class, which is the passenger class. So passenger class 1, 2 and 3, and it has the survival rate. We can see here the people who traveled on class 1 had a very high survival rate, over 60%, whereas people who traveled on class 3 had a very low survival rate. So this helps in understanding about the importance of these attributes as well, and it made sense to use these features unchanged, because it is providing a lot of information. And the next one is a similar chart. So what we are going to do is we are going to see how many people so here in the above one, we saw the probability of survival, how many people as percentage of the total people who traveled in that particular class. So let's say if in case so this is not happening in this particular data set. So here the probability for people who traveled in class 1 is over 60%, but let's assume that number of people who traveled on class 1 is only 10 people, and 6 of them survived and then 4 of them did not survive, whereas people who traveled on class 2 and 3 is on scale of over 100. So then it doesn't make sense for us to use this particular feature. So in order to understand how is the distribution, so what I have done is I have got the count of people who traveled on those different classes, and here we can see that the number of people who traveled in class 1 is not very low. It is low as compared to class 3, but it is still a significant number, and hence we can directly use these features in our model. And coming on to the next one, to see number of people who had siblings and spouses, and then how their survival rate, so this tells us that when a particular person traveled with a larger family, did he have an higher survival rate or not? So here this tells us that people of family size 2, so this is apart from the passenger, if they had maybe one more sibling or maybe 2 more siblings and spouse, they had higher probability of survival, whereas when they were traveling alone or when they were traveling with a larger family, so their survival rate, people with the family size of 4 had the least survival rate, even less than 20%. So these helps in tells us that when they had traveled in a smaller family group, they had a better survival chance. And then the next one is number of parents and children. So here, so this one is almost a similar kind of data set. So this tells us that number of parents and children for the passengers. So here, when there was no parent or children, which means that passenger was traveling alone, so the survival rate was 34, which is matching with the previous chart. And as the family size increases, we can see people with the family size of 4 and more almost had like a very low chances of survival, like yeah. And then moving on to the next one, like whether people boarded from different port, does it have any impact on the survival rate? So here we can see that people who embarked from the port C, so if we go into the actual data set, we can see C is for Cherbourg, Q for Queenstown, and S for Southampton. So we can see like people who majority of them boarded from the port Southampton, and the survival rate has been the least, like 33%. And doing further analysis on these attributes, so we can see the same data being represented in a visual format, and to give us a better understanding, because like visual data, generally it's very easy to grasp the information. So in most analysis, it's better to use the visual representation rather than tabular representation. And the other last two analysis is about multivariate analysis, trying to combine different attributes like a gender, passenger class, as well as survived flat, and then see whether there is any pattern out of it. So these helps in understanding when we combine, and when we study one attribute in combination of two or more attributes, see how the data is behaving. And similarly, the next one is we are trying to add the port from which they had been boarded into this information along with the passenger class, to see if there is any difference in the survival. So that's about the data analysis. So today in this session, what we have covered is we have covered about doing the data analysis. So we haven't modified any existing data, so we are using the data as such, doing the analysis, try to get a better understanding about what the data is looking like. So based on this analysis for Titanic Dataset, we can clearly understand that there is a large number of outliers for fare, and there is a bit of skewness for age, and passenger class definitely seems to be a good indicator in making the prediction. And similarly, like a gender as well, like females had a very high probability of survival. And moving on, port from which the passengers have been embarked seem to have some kind of information. Majority of them boarded from Southampton, I guess. Yeah, 644 people, and then it had least survival rate. So maybe that is something that tells us that this attribute is an important feature. And we also see that the family size plays an important role in predicting whether they would have survived or not. So this data analysis gives us a good understanding about like how the data is distributed, and it helps us in better understanding about the actual data set. So moving on to the next one, like in the next session, what we will do is we will study about the data transformation, how to transform like attributes such as age and fare into different groups, like what kind of techniques we can use them. And similarly, we will also be going through the string categories, for example, like port from which they have been embarked, how to transform them into numeric categories, so that it makes it easier for the model, like when we have integer categories. And that's about it for today. If you have learned something new, and if you enjoy learning here in my YouTube channel, please give a thumbs up and subscribe to my channel. If you think this might be helpful for any of your friend who is learning data science, please share it with them as well. Bye for now. See you in the next session.